Simplifying Exponential Expressions with Savannah and Dina. Welcome! Today we are going to be talking about solving exponential expressions and simplifying them. We're going to show you some formulas and then some examples of the formulas to apply the formulas to equations. Let's get started.
So here's our first equation. We have x to the m times x to the n. So what you're going to want to do in this situation is we're going to have x, and instead of multiplying m and n, we're actually going to add them because this is a rule of exponents. So you have x to the m plus n. So our example here is we have 4x squared times 3x to the 6. So we're going to want to multiply the coefficients together, which is 4 times 3 is 12. And then we want to add the exponents, which is 2 plus 6, and then we have 8. So our answer is 12x to the 8. And then our next equation is we have x to the power of m in parentheses to the power of n. So it's going to be different than the last one because we're actually not going to add it. Because it's in parentheses, we're going to multiply the exponents. So this will be x to the m times n. So our example here is we have 2x to the 3 in parentheses to the 2. So our answer is going to be 2x to the 6 because we're going to multiply the exponents, which is 3 times 2, which gives us 6.
Our next example starts with x raised to the m divided by x raised to the n, which is equal to x raised to the m minus n. So in this case, in the division of two exponential equations, you're just going to minus the exponents from each other. Our example of this would be 6 raised to the third over 6 squared, which is equal to 6, and then just minusing the exponents, 3 minus 2, which equals 6 by itself. Our next example is xy in parentheses raised to the m, which is the m distributes itself equally to the x and the y because of the parentheses. X raised to the m times y raised to the m is how you do it. An example of this would be 4 as our x and 12 as our y and 3 as our m. So, the 3 distributes itself to both the 4 and the 12 in this example. 4 to the third and 12 to the third.
Our next equation is we have x over y in parentheses to the power of m. Now remember, because it's in parentheses, we're going to want to equally distribute the m to both x and y. So what we'll get is we'll have x to the power of m over y to the power of m. So our example, we have 8 over 4 in parentheses to the power of 2, which is 8 squared over 4 squared, which we know is 64 over 16, and our answer would be 4. Now our next exponent rule is we have x to the power of 0. Now this is easy. Just remember, whenever we have a number that is to the power of 0, it's just going to equal 1. So our example is we have 7 to the power of 0, which is 1. Now if we were to have 8 to the power of 0, it also equal 1. If we had 400 to the power of 0, it would also equal 1. Now here's another simple exponent rule. Whenever you have x to the power of n, it's just going to equal x. So our example is we have 4 to the power of 1, which just equals 4.
Our next example is x raised to the negative n, which in this case, when you have a negative exponent, it switches it around into a division. So x is on the bottom and 1 is on the top. An example of this would be 5 raised to the negative half, to the negative square root, which is equal to 1 over 5 squared, which of course you know equals 1 over 25.
Now our last equation, and this is our most difficult one because it deals with radical numbers, is we have x to a fraction. So we have x in this situation to the power of 1 over n. So what we do here is that our equation becomes n to the root of x. So for example, we have 2 to the power of 1/3. So what we do is we actually bring 3 over here and we make it a root of 2. Most cases you're not going to get a perfect number, whatever we cube root things. So let's look at our calculator. Let's calculate. So you get the cube root 2, which is going to give us 1.26, which would be our answers. So that's how we simplify exponential expressions. Does anyone have any questions?